Hi guys, welcome to Safi Mixed. In this video, I want to solve a problem in mechanics that would give you intuition how to fix conditions on the solution of problems. And this is and what I'm doing in this video is very intuitive. It will fix two conditions. Consider that there is a single track and two cars or two trains are moving in the same direction. This is, let me call this car B, and there is another car, I call this car A. They are moving in the same direction and the separation between them is L. Let initially the velocity of car A, VA, is greater than the velocity of car B. Obviously, VA is greater than VB. With the passage of time, this car will be approaching car B and there may be a collision, an accident, and we want to avoid that. So in order to avoid that, that's real obvious. This driver, the driver of car A, needs to reduce its speed. If this distance is not very large, it is very little, then obviously this car has to decide very quickly to reduce his speed. And when can the accident be avoided? Obviously, when the speed of car A reduces to the speed of car B. That is, this is one condition. VA should be equal to VB, and that should be done, that reduction in speed should be done in time before the two cars, the two bodies touches each other. So there is condition of time, and obviously both the cars are moving. Car B is moving in that direction, car A is moving in that direction. So the two cars in that time, which is needed to reduce the speed from this to this condition, the two cars had moved ahead. That is, in time t, this car would have moved to this position, this car would also have moved to this position, or so on, we don't know. So I call the distance covered by car B to be SB and the distance covered by car A to be SA. Now, there will be no collision if the distance covered by car A is lesser or equal to SB plus L, and time needed to reduce the speed from this condition to this condition. If this condition is satisfied, there will be no collision between the two bodies, between the two cars, and the collision is completely avoided if the upper condition, that is SA, is lesser than the sum of these two parameters and would be just the touching each other if the equality is satisfied in this equation. So what we need to do, we need to find the constant acceleration, that is another condition, the constant deceleration of car A in order to satisfy this condition. So the initial velocity of car A is VA and the final velocity, we set this to VF, of car A needs to be VB. So what do? We want to use first VF of car A is equal to VA plus AT. That's the equation to find the final velocity, and we want to set the final velocity to VB, so I just replaced that VB. This is for car A. In this equation, and from this equation, we can find the condition for time, that is T equals VB minus VA divided by A. I call this in equation, let me call equation 1. Okay, now the distance, we need to find this distance. The distance covered by car B in this time is in fact equal to SB equals VB into T, and putting the value of T, I can put this in the form VB times VB minus VA divided by A. Okay, and obviously the distance covered, let me call this equation 2, and the distance covered is A, and this time bicar A is then given by, since we know the final velocity to be VB and the initial velocity, we can write the distance in terms of acceleration to be 2A is A equals VB squared. This is the final velocity of car A, the needed corner velocity, minus V A squared. This is the initial velocity. And from this, I can write is A equals VB squared minus VA squared divided by 2A. I call this equation 3. Now, I want to put the values of SB from equation 2 and SA from equation 3 in the given condition, and want to solve this. So that I can do, let me remove these things, and I want to write it over here. If I put these values for SA, I write VB squared minus VA squared divided by 2A, and I want to consider the extreme position, that is, I want to put this to equal. The less I ignore the second condition, and then put the value of VB, which is this one. So VB into VB minus VA divided by 2A, and then this distance L plus L. Now I want to solve this relation for acceleration A, and that I don't need any of them, and I can solve this equation to multiply both sides with 2 times A. It would give me VB squared minus VA squared equals VB into VB minus VA plus 2AL. Or I can write this as VB squared minus VA squared, and I'm taking this to this side, so that will become minus VB into VB minus VA equals 2AL. I open this bracket to write this as VB squared minus VA squared minus VB squared minus VB times VA equals 2 times A times L. I can cancel this VB squared with this VB squared, and this would give me minus VA squared minus VB into VA equals 2AL. Or I can write A equals minus VA into VA plus VB divided by 2L. So now, if we know about the two initial velocities in the initial separation, we can find the negative sign says that this is deceleration. We can find the deceleration. And now if I give numerical values to these quantities, I can, let me call this 97 kilometer per hour. That is, car A is moving with this initial velocity, and this one is moving with 48 kilometer per hour, and the initial separation between them is 60 meters, which is equal to 6 into 10 raised to the power minus 2 kilometers. If I put these values, I can write this as minus 97 kilometers per hour into 97 plus 48 kilometers per hour divided by 6 into 10 raised power minus 2 kilometers, and 1 kilometer from the numerator cancel with this with the kilometer in denominator. We are left with the kilometers per r squared, and I can convert this to meter per second, would give me 1.5 meter per second squared. So if car the driver of car A decelerate his car with this acceleration, with this constant acceleration, there will be no collisions between the two cars. Thanks for watching.